Our final notes for the unit pertain to percent yield. So a theoretical yield is what we've been calculating on paper, and it's the amount of product you theoretically could get from a chemical reaction. This is the maximum amount possible for a perfectly efficient reaction. You'll have to do a stoichiometry calculation to get a theoretical yield. The actual yield is the amount of product you actually get in the lab. This one is usually given to you in the problem unless you're actually doing the lab. So the percent yield is the actual yield divided by theoretical yield times 100. The actual yield is going to always be the smaller value, and the theoretical yield will always be the bigger value. You should never have more than a 100% yield. So our first example, ammonia is made through the reaction of hydrogen and nitrogen gases. 5.0 grams of hydrogen react with an excess of nitrogen. So we have an excess of nitrogen, 5.050 grams of hydrogen, and we're producing 20.4 grams of ammonia. It's important to realize that this is equal to the actual yield. And we are going to use this given right here to figure out the theoretical yield. So we're going to do a theoretical yield calculation. Again, we're going to take the coefficient times the mass in the periodic table for hydrogen, and then here we'll take the coefficient times the mass for ammonia in our calculation. So when I set up my proportion, I'm going to get 5.50 grams of hydrogen equals, and we want to know X grams of NH3, and then down here it's going to be 3 times 2.02 grams for hydrogen, and over here it'll be 2 times 17.04 grams of ammonia. When I do the cross multiplication here, I get 5.50 times 2 times 17.04 divided by 3 divided by 2.02, and that's going to get us X equals 30.93 grams of ammonia. And it's important again to note that this value right here is our theoretical yield of ammonia. So now that I have my theoretical yield by doing a proportion and my actual yield, which is given to me in the calculation, I have this here. The actual yield is 20.4 grams of NH3. We calculated the theoretical yield, 30.93 grams of NH3. And now to get the percent, we're going to take the actual 20.4 divided by the theoretical 30.93 times 100, and that gives us 65.96%. So this is 65.96% of ammonia that was actually yielded in the laboratory. Sometimes a problem will give you the percent yield and the theoretical and ask you to calculate the actual, and we're going to use the same formula. I'll show you an example below. So in this case, a reaction theoretically produces 24 grams of a substance. This is my theoretical yield. And then notice here we have the percent yield. And they want to know what is the actual yield. Well, if we only made this percentage of the total possible, which is the theoretical yield, is the 100% total possible, then you basically just take your theoretical yield, 24.0 grams, multiply it times your percentage, but be sure to change it to a decimal first, 0.50, and then that is going to give you your actual yield. We only made a 50% yield of our total, so if the total was 24, we only made 50% of it. We only actually made 12.0 grams as my actual yield. So take your theoretical times the percentage after you change it to a decimal, and then you'll get your actual yield. How many grams of sodium oxide, so how many grams of this can be formed from 20.0 grams of calcium oxide. So below it, I want to put the coefficient times the mass, 56.08 grams. And then over here, the coefficient times the mass of roughly 62 grams. I did round that off here. And so what I'm trying to determine is when I get this answer, that answer is going to be a theoretical yield. So we'll set up our proportion where it's 20.0 grams of calcium oxide over 1 times 56.08 grams is equal to X grams Na2O over 1 times 62 grams. We will solve this proportion by cross multiplying here 20.0 times 1 times 62, and then I'm going to divide by 1 divide by 56.08. And that's going to get me 22.11. So X equals 22.11 grams of Na2O. And again, this is a theoretical yield that we just solved for. Final example. Use the equation below to answer the questions. Here's my reaction. How many grams, so question mark grams, of FeCl2 can be produced from 34.0 grams of FeBr2? So now I'm going to take my coefficient times the mass of this from the periodic table, which is 215.65 grams. And then over here, I'm going to put the coefficient times the mass of iron 2 chloride from the periodic table, 126.75 grams. So what they're asking me to solve for over here is the theoretical yield of iron 2 chloride in grams. So how many grams of FeCl2 are we going to get from this? We're going to set up our proportion. So we have 34.0 grams of FeBr2 over 1 times 215.65 grams equals, and then over here, X grams FeCl2 over 1 times 126.75 grams. We're going to do the math by cross multiplying here and then dividing by 215.65. And so we get 34.0 times 126.75, and then I'm going to hit divided by 215.65. 19.98 is what we get. So X equals 19.98, and that's grams of FeCl2. And once more, this is equal to our theoretical yield. Now, if 4 grams of FeCl2 are produced in the lab, that means that this value is the actual yield. And they're asking what is the percent. So remember that it's actual over theoretical times 100 equals the percent. So my actual is 4.0 grams divided by this theoretical that I calculated times 100, and that's going to get me my percentage of 20%. So this answer is 20%.